Hello, my name is Max and welcome to this tutorial today where we're going to program a simple snake game using JavaScript and HTML. Before we get started, I just want to go through some basic snake game theory and the data structures we're going to use when we program the game. So to start off, I just want to describe the grid data structure. So it's useful in games where the game word is confined in absolute size chunks of data or information. In our example, that will be the game board. That will be represented with a grid data structure, and in each cell we can have an ID what that cell contains, and by drawing different sized colored boxes, depending on what is the ID in that particular cell is, we can get a graphic representation of the game. And it can be represented in numerous ways. In our example, we use a 2D array. So this is the example I was talking about. So this is the data structure of the grid, and on the right here you can see the graphic representation. And then by shifting position of different elements in the grid, for example this 0 here and this one here, we can make the snake move in this fashion here. And by doing that process, we do the game tick, or the update of the game. And here, by listening to the input, keyboard input from the user, and change the direction depending on what the user have pressed, we can get a game, actual game, and not just some blue boxes moving across the screen. We are adding interactivity to the game. So this is the interface of the grid, and it will just have a width and a height field, and that is the amount of columns and the amount of rows of the grid. And then it will have a meet, set, and a get methods, and they just initiate and set and get. They are just pretty self-explanatory. So the snake will be implemented as a queue, with abstract as a queue, and that is described by this keyword here, FIFO. That means first in, first out, and it will contain all the data of the current position in the grid with the snake ID. And it has a direction which is controlled by keyboard input, and it's represented in the grid with ID, of course. So here's the interface of the snake. So it have the direction and the last fields here, and that just means the direction, and the last pointer is used when we are shifting position in the grid. And then the init, remove, and insert methods are just taken directly from the queue interface. Almost. The D here is just to set direction, initialization, a start direction for the snake. And then the fruit item, or food item here, represented only by an ID in the grid, and the position is set randomly by this function set food, and it will set the fruit item at a random free cell in the grid. And then for drawing and graphic representation, we're using HTML canvas, and we're just going to use the field style, width and height fields, and then the context and field rect methods. And for animation, we'll be using the window request animation frame, as is widely supported now, almost in most of the modern browsers out there. So it will be no problem for us to use request animation frame for this example. Anyway, let's get started by programming our actual game then. So I'm just gonna save a file here, save it on a map and computer, snake HTML, and in here just grab some basic HTML5 stuff here, so simple snake game, something like that. And then in the body, all we need is a script tag, more or less. And let's start by specifying some constants. And the only one we need is the number of columns, I guess. So that's 26. You can of course set to any arbitrary value you want here. I'm just going to use constant 26, and then we do need some IDs, and then we need for empty, I'll set that to 0, and for snake set that to 1, and for the fruit set that to 2, like that. So let's start by making our grid here. The width, initiate that to null, the height, initiate that to null as well, and then inside the grid we need a representation of the grid, and that is this underscore grid stuff here. So let's do the init method, and that took a direction and number of columns and number of rows like this. And then did we have a set method to val at x and y position. and lastly a get function, and that just x, y, like so. And then the snake, it will be quite simple to do that as well. So we have a direction, which that null, and then inside of it we need a q here, so set initialize null as well. And I have the init function method to get direction and a start position here, and then we have the insert method that is to an x and y, like so, and then we remove. It took no arguments and like that. And then do we have, right now I'm just writing out the boilerplate for our game, if you're wondering. And then we have the function set food, like that. And then we need some game functions. So that will just be a main function and a loop function, update function, I guess, and lastly a draw function. And in the end of the file, make sure you call the main function like that. And I forgot one function here, the init function, like so. So we can start by implementing our grid structure. That's quite simple. You just want to set the width to the number of columns here, and the height to the number of rows, of course. And then do we initiate the grid here to an empty array, and then do we loop some stuff here. So var x equals 0, x is less than c, x plus plus, like that. And then do we loop for var y equals 0, y is less than row, then y plus plus, like so. And then here we just want to push an empty array in here, and then in here we want to set of the current current column, so that's this x here, and then we're just going to push in a new value there for each y in that column, for each row in that column, and we just put in the default value here that you set in the parameter or argument to the function, to the method, sorry, like that. So that's it for the init method. And the set method is really simple. It just is a grid of a certain position, x and y position, equal to vol, like that. And then for the get, it's simple that also, that just return this grid x and y, like that. So that's it for the grid data structure. So let's do the snake, and this dot direction equals to d, and then do we say this dot q equals an empty array or empty list, and then we just say this dot insert x and y, and I almost forgot the last field here. So yeah, so in insert it's quite simple. It's just this dot q dot unshift. That means put at the start of the file, and we just put the x object here and the y JavaScript object like that, and then do set this dot last equals this q at 0, and remove here, it will just return this q dot pop, like that. So that will last for the snake. So let's do the set food here. So we need to track all the empty places of the grid. So we just initiate that empty array like so, and then do a loop through all the stuff here. So var x equals 0, x is less than grid width x plus plus, and then we do another loop here for var y equals 0, y is less than grid dot height y plus plus, and then do we just say if grid dot get x and y equals to or is empty, like that. Then we say empty dot push x and y. that. And then we just get rand pos equals empty, and then we get a random element in that array. We can just do this. So mat.floor, mat.random times empty.length. And you can think about it by yourself, but that will give us a random empty element. And then we just say grid.set fruit at random position.x and random position.y. So that's it for our data structure that represents the game. And then here, for these functions work, we of course need some game objects. So we need a canvas, I guess, and a context, and then we need a key state and a frames variable. Those we will need use in a moment, but those we do now. So let's get started. Just initiate canvas, a document, create element canvas, like so. Let's set the width of canvas to the number of columns times 20, I guess. Let's set the height, if I can spell it right, to number of rows times 20, like that. And let's set context to canvas to get context, 2D, and then let's append. So document body.append child canvas, and then it's called the init function and the loop function. And we can actually initiate our frames here as well. So frame set to 0 and the key state to an empty object, like that. So the init method function, all we want to do is called grid.init, and we of course want to set each of the cells in the grid to empty, and the number of columns and the number of rows again. And then we set start position here of the snake, and that will just be mat.floor, so we can have both odd and even number of columns divided by 2, like so. And the y will be set to rows -1. Then do we say snake.init, and we can set the direction variable. We haven't set it, or did we? No, we did not. So let's set some direction here. So that will just be left, up, right, and down. And let's set the starting direction here to up, I guess, and then sb.x and sb.y. So, and we will set a snake at start position.x and start position.y, like so. And then of course we want to set the food item. And the loop, we just want to call the update function and the draw function. And then we say take this window request animation frame that I was talking about, and that you take the loop and a canvas as a function, a callback function, and a canvas as arguments. So the frames update we can leave empty for now. We can just increment the frames variable. And in the draw we need the tile width, so that equals to canvas.width divided by grid.width, and the tile height, that canvas.height divided by grid.height, like so. And then do we just loop again, so we can just copy some code from up here, copy this code here, I guess. So let's do that, like so, and then let's go to the rest inside here. So in here, let's do a switch statement of the grid.get of x and y, and we have all the cases here. So we have case empty, case snake, and case fruit, of course. And all of those, we just want to set the field style to color. I just set alt white for now, and then do we want to break. Don't forget the break there, guys. And then I just change the snake height to a cyan color and the fruit to red, why not? And I just do a fill rect of x times tile width, y times tile height, and then tile width and tile height. Just like so. So now, if we open this file up, so supply projects, tutorials, and here, if I open this up in a browser, and if I reload the page here, each time the food item here will get a new random location. So that is working fine. So let's actually do some updating, shall we? But before we do that, let's add some styling to the page. So let's do that to the canvas here. Let's set the display mode to block, the position to obsolete, and let's set the border 1 pixel, the solid let's set black, and then set the margin, and then by setting the margin to 0 auto, sorry, and then setting the top, bottom, right, and left variables here to attribute, sorry, to 0, you will get the canvas centered at the screen, middle of the screen. Yeah, so let's do the update. So this is real simple. So just increment the frames here, and then we say if frames modulus 5 is 0. So each 5 frames we want some stuff to run here. So we set a variable here, new x equals to snake.last.x, and then we have new y equal to snake.last.y, like so. And then we do a switch statement again, of course, but this time of the snake.direction. And then all the cases here, so we have case left, and case up, and case right, and mostly a case down. So here, of course, we just want to change then the NUX and UI, but they follow a simple pattern if you have set them up the way I just did. So just change each second to NY, and then just add pluses to the end here. And then by taking out the tail here, set that to snake.remove, remove, and then set the grid here, so grid.set tail to empty of the tail.x and tail.y. Then by setting the tail of x to nx, tail of y to ny, and then by setting again here to a snake at the new tail x and tail the y, like so. And don't forget to put back in the snake, so snake insert here, tail.x and tail.y. So now, hopefully, if I've done this right in the reload page, the snake will be moving. So yeah, it seems to be working fine. As you can see here, it is going outside of the canvas or the border, and we don't want to do that. So let's fix that real quick. So we just do a simple if statement here. So if 0 is bigger than nx, or nx is bigger than number of columns, or sorry, the grid of width minus 1, or 0 is bigger than ny, or ny is bigger than the grid dot height minus 1, like that. Then we just want to return init like that. So now, hopefully, if the snake goes outside, yeah, it will reboot the game for us. So that's really good. So, but that's no good. So let's actually make it possible for us to control the snake. So to do that, we need some key codes. So let's set it here, so key codes, and I just looked them up on the internet beforehand here. So for left, you can say key left, that's equal to 37, and then we have key up, and that's equal to 38. It should be 37, not 27, and then we have a key underline right here, that's 39, and then we lastly have key down, and that's 40. So that's all the key codes we need. So let's get down to the main function here, and let's capture the key state or key code that is pressed. So document add event listener like so, and key down. Let's take a function with an event attribute like so, and let's just copy this down like so, and change this to key up, I guess. And in here we just want to say key state event dot key code equals true. I need to remove och the key up. We just want to remove it, so delete key state event dot key code. So that's it. So now we should have working capturing of the key states. So let's just update the direction of the snake then. So here we can just say if key state key left, then we want to set the snake dot direction equal to left, of course. And then just copy this down 3 times, and we can change this to up. And if I could, yeah, and then we have right, of course. And lastly, do we have the down. So from now, if I reload it, I should be able to control the snake. Yeah, and that seems to be the case. But as you can see, if I move over the fruit here, nothing will happen. So let's fix that case right now. So that's really simple. I just say if grid dot get nx ny equals to fruit, then we just want to set a new foot position. So set foot like this. So now each time I go over here, it should set a new location. So that works. But the snake isn't growing. So let's fix that. So then, if this is the case here, if the head is on a fruit item, then we just want to set a tail item here to a new item with nx and y to ny like so. Then we say else statement here, and then we just grab all these up here, I guess, and just tab it in here. And hopefully now the snake should grow. Yeah, so that seems to be working fine. So the game, it's now finished. It's just one thing, or not finished, if I try to hit myself, nothing will happen. So let's fix that also. So that's really simple. It just add a not if statement here, or if condition. So that is just if grid dot get nx and ny, if that equals to a snake path, then we want the game to reboot again. So now if I try to hit myself, it's gonna go a bit bigger. Yeah, now the game rebooted. And it's just one thing left to fix, I guess, and that is if you move back into yourself, the game will reset also. So to fix that, so you can't move back into yourself most of the time, at least, then you can just add and statement here. So if snake dot direction not equals, and then here we can put some conditions here. So if the left, you put the right, and if you take up, you take the down. So just take the opposite direction, of course. So left here, and then here is up. So now I can't be moving inside of myself again, and that will make the game not as frustrating for users. So we can add one final touch to the game. Let's add a score system. So let's just get down here over the main function and add a score field, and then init, let's set the score to 0, and each time we hit a food item here, we can increment the score, so score plus plus, and then in the draw, let's just draw it. So ctx field style, let's set that to black so you actually can see it, and ctext of fill text. And let's set score here, so score plus score, and then add some position here, so let's say 10, and then canvas.height minus 10. So now we have a score in the bottom left corner of this canvas. That's a bit small to see here, so let's in the upside here, let's set the font, so font equals 12 pixels or something, and let's set Helvetica. You can of course, yeah, I don't think that was right spell, but at least it was a bit bigger, so I'm happy. And then, yeah, so that was it, guys. We know how I'm working. Snake game, a real simple snake game, quite fun to play, and it is easy to play around with, and yeah, thank you guys for watching. Next time I will probably program another game, Pong game or something like that, and I look forward to see you then. Thank you for watching. Bye.